So, hello and welcome to the NFDI Talks. I'm Elena and I'm working in the NFDI Association's head office. In our NFDI Talks, every 2 weeks, scientists from different disciplines present exciting topics around research data infrastructure and management. All talks are live streamed and saved on our YouTube channel. Exclusively here in Zoom, we invite you to discuss the topics and ask your questions after the presentation. So in this episode, we will take a closer look into the NFDI consortia NFDI for Energy. Energy systems are currently changing in multiple ways due to the need to reduce CO2 emissions, new technologies, and digitalization. In the talk, we will learn about the typical research artifacts in energy research like data and software, and the challenges researchers have with them. Also, we will get an overview on the services NFDI for Energy will provide to support researchers with these challenges. Today's speaker, Astrid Nieße, is a professor for digitalized energy systems at the Karl von Ossietzky University of Oldenburg. She is part of the board of directors at Office, a computer science institute, where she is responsible for the energy division. Her research focuses on how energy systems can be controlled more efficiently with the help of digitalization on the one hand, and how energy research can be supported through digitalization on the other hand. She is the spokesperson of NFDI for Energy. So now, please welcome with me, Astrid.
Thanks a lot, Elena. Thanks for the very nice introduction, and thanks for the opportunity to present some of our ideas from NFDI for Energy. So I will talk today about a creation of a research data infrastructure for energy system research. So first of all, why? Why do we want to create a research data infrastructure for energy systems? As Elena already said, energy systems are changing a lot due to the climate crisis, due to the changes that are needed in our energy systems. That is for many reasons. You know that photovoltaics are coming and wind energy plants are changing the system and its behavior. We see a lot of storages coming in, smart grids, battery storages in houses and outside of houses. And of course, electromobility is important here. And all the questions connected here sometimes touch you in your most private life when it comes to the question, what will the energy systems look like in the future? And these kind of future scenarios are not that easy to tackle. How will they look like in the end? So we have economic questions that are involved here. And of course, we do have other questions. So what will the photovoltaic plants deliver as energy in the future? How do we exactly know that? And what are the laws and what are the data that are needed for the political people to set up the most efficient framework here? So these are a lot of questions that all tangle future scenarios in energy research. So let's have a look at an example. Energy research. Let's take two researchers that have a question. How do we model the multimodal flexibility of smart buildings? Multimodal means that there are different devices in the system and they may deliver flexibility to different energy systems like gas system, heat system, power systems. So these research want to work on with respect to these questions. Let's see what they need for that. They need a lot of input. Some research artifacts, as we put it, they need code, they need knowledge about what other researchers find out, and a lot of data that are needed, for example, for their simulations. Well, some of these input data they do not find. They will never find it, although others might have it. And others they will find, but they are not able to use it because they have interoperability issues with that. So and in the end, they will somehow manage to do that. A lot of stuff probably will be, produced again and again, but in the end, they will do their research and then they will have research artifacts again as output. And they do not know where to put it in the end, although they would be willing to do so that other researchers would be able to reuse it. So research artifacts should be reusable. That is quite clear here for many, many reasons. That the researchers all feel and that they want to, deliver their part. So we want to help these researchers, but not only these researchers. But let's start with this group. We want to build an open ecosystem for fair research artifacts in energy system research. So what does this mean? We have a lot of goals in NFDI for energy. We want to establish common research community services to allow reproducibility, transparency, and reusability of research artifacts. We want to simplify the identification, integration, and coordination of simulation-based models. And of course, we want to support the use of these services in the research community, because as you know, it's not always that easy to, well, use a service that you once find. And we will come to some examples a little bit later. Of course, we want to enable and motivate the involvement of society, because energy systems tangle everyone in the end. As I already said it, in your private lives, you will come across the same questions later on. So society is very important. And of course, it's a matter of business. So industry is very important here. We want to promote better collaboration and knowledge transfer between scientific research institutes and our business partners. And as you will see at the end of my talk, we want to integrate the provided services within the wider NFDI ecosystem. You maybe learned something about the wider NFDI ecosystem in the last talks. So all these goals are part of our goals in NFDI for energy. First of all, let's introduce our consortium. So as you can see, we are spread all over Germany. We have experts, for example, from the area of power grids and automation systems. Other experts are in the area of long-term energy scenarios. Energy policy and societal aspects are tangled by some of our partners as well. And of course, we do have infrastructure and service providers in our system, because that is in the end where these services have to be provided for the researchers and all our stakeholders in the end. So let's again now have a look at our goals after I introduced our consortium here. So for whom are we going to develop our services? Oh, of course, there's a lot of network involved as well. I will not go into details here. So let's look at the goals. What are the stakeholders? You see here, 3 of our goals show our stakeholders. That is the research community, the society, and the business partners. And these are very diverse stakeholders. Let's have a closer look into what they need as part of the energy community. The research community is, of course, the main producer and user of research artifacts. They need additional tools for handling of research artifacts. And of course, as you might think, they really don't want to spend all their lifetime on understanding how to use the services. So there is definitely a need for easy information on the services. Let's look into the second group of stakeholders, society and policy. They need robust data and social and political factors because they are essential for energy modeling, and that means they are essential for wise decisions on how the energy systems should look like in the future. There is a high need for communication of scientific results to these stakeholders, because we have to explain them what they need as information for their daily work. And of course, our industry is there as well. There's a high relevance of data from the business partners, because this is important input to our research. And there is a need for anonymized and artificial data. But typically, our business partners do not have an easy access to anonymization of these data that they produce in their daily business. And of course, it's not only on sharing data between business partners and research, but there is also a huge need for sharing data between business partners in a way that is legally okay, and that everybody is sure that these data might be shared. So you see very different stakeholders. So how do we collect the requirements of these 3 groups in detail? We have multiple mechanisms here. Of course, we collect requirements with a methodological mix, interviews, surveys, and workshops. We involve the community. We go to a lot of workshops. And of course, we do workshops with our industry partners as well. And you might have already seen us on different conferences or other events, of course, where we discuss our ideas and want to understand what happens. So up to now, we did not dig deeper into what kind of services we want to develop in detail. So let's go back to one of our goals here. We want to simplify the identification, integration, and coordination of simulation-based models. So why simulation? So simulation is very important in energy system research because we are in a critical system. We are not able to, develop everything in place out in the field. We always have to take the simulation route first, then we go to the lab, then we go to some kind of field trial. So it's a long route. Simulation thus is of major importance here. So this is one of our goals. And we need, we take this example now to understand what are our data, what are our digital objects that we want to have a look at. There are some examples that we want to tackle here. So for example, there are data sets, of course, that is what you would think about first. So time series like weather and power input, some parameters of devices and demographic data might be some examples. Software is very important in energy system research, like grid computation frameworks, co-simulation frameworks, or agent-based simulation frameworks if we want to understand how people might work and react in our systems. Some simulation models are needed, of course, as well, like models of wind energy plants or networks and so on. And of course, I already talked about the scenarios. So energy system transformation always comes with ideas on long-term and short-term scenarios. So how will our energy system look like in the next 15 minutes, but also in maybe 5 years or 10 years from now? So scenarios are quite important here. Interestingly, we do not have benchmark scenarios for all kind of energy systems projections in the future at the moment. So this is quite important to work on the benchmark area as well. And user acceptance is, of course, of major importance because otherwise we develop stuff that will not be accepted and thus not realized later in the future. When we have all of this, still, we might have some problems in energy system research. For example, when it comes to comparability of how we analyze stuff. So workflows on how to do a detailed simulation, how to configure a simulation framework. That is not so easy. So of course, some workflow information is important as well. And when it comes to public involvement, of course, there's one example. So research artifacts are quite important. Digital objects are important. Some example, just because to stress the aspect that software is important here, we do have different simulation tools that we work with in our daily life. So here are some examples that we need in simulation of energy systems, Mosaic and Rulas Web from our partners here. So let's come back to the services. What are the services that we need? To better understand this, we go into the area of research data management to understand the life cycle of research data in energy systems. So this is a kind of life cycle of research data management. It might be familiar to you because it's not specific to energy system research. So let's have a look at the questions involved here. Just one example. So where do I find reusable research artifacts? Where do you start your search? Probably you will ask a colleague, but if there is not a colleague, whom do you ask? Where do you look for? Where and how should I store my research artifacts internally? So internally during your research. But in the end, how do I publish my research artifacts so that others might benefit from it? And that maybe even I benefit from it because my research artifact, well, evolves over time because others contribute as well. In which format should I produce my research artifacts to alleviate this problem, to make it easier for others to reuse it? So these are very different questions here. We dig a little bit deeper into parts of it. For example, we want to help to navigate in an interdisciplinary field. So a provision of a database for profiles from scientists and industry partners open to new ideas might be relevant. We want to provide research networks through visualizations, and we want to provide an overview on existing databases and experimental setups. If you're an established researcher in the field, this might be not so important for you because you do have your network. You do know who is the one to ask for specific questions, for specific data profiles, and so on. But if you are new to the field, or if you expand your range of questions in energy system research, it might be not that easy. I always take the example of working with people from politics or the social sciences. That is not my original networks because I am a computer scientist and I'm from energy informatics. So people from the political science are not my, well, kind of home base. But of course, I need their expertise in energy research. So I need this kind of information that can be seen here. So let's go to the next example. How do we help to produce and store fair data and results? We want to provide recommendations on existing repositories using a registry. We want to provide terminology services, and we want to provide a tool for assigning persistent identifiers to the FAIR research objects to allow for interoperability, to allow for the automatic integration of different models and results to our research. Parts of this can be done by linking our results to the open research knowledge graphs, or the different knowledge graphs, of course. And for this, metadata might be very important. Just to give you a recent example from the work we did here is, it is based on working with the open research knowledge graphs. And this example here, you can see some results from our working groups here, a colleague working on the robustness of cyber physical energy systems. And as you all know, the first step in writing a paper in a new area for you is always to find out about the state of the art. And how do you do it? Well, if you use the Open Research Knowledge Graph for that, you start to develop kind of information in the graph on what has been done. And you see here that the results have not been published as a normal publication, but as part of the knowledge graph for others to use it again. How is this done? You create, of course, different contributions in this area, and you extend your knowledge by using the knowledge from the publications and integrating it via the needed metadata. So for example, as you see here, this is one contribution, so a publication that has been analyzed by our colleague here, and she found out that this is obviously working in the area of attack and cyber attacks, and there is a denial of service attack in more detail. So as you see here, the important information is tackled and analyzed. So later on, this information can be used to couple the different results that comes out of our colleagues' work in this area, just as one example. So let's go to the next example, to couple and analyze the different models and data to one simulation scenario. So let's say our colleague Emily now set up a simulation herself, and now she wants to, well, simulate the system. Typically, she has to do a lot of work to get herself familiar with the tools, Mosaic, Villas Node as the two examples already mentioned here. We want to somehow take part of this burden of getting familiar with these simulation tools and set up an easy to run simulation as an online simulation. So co-simulation online as a simulation as a service setup is something that we want to set up here for ease of use and for scalability, because scalability, as you might know, is an issue in co-simulation. So now Emily does have her results, and she wants to make the results reusable. So what does she do? She, of course, needs an overview on the best practices on how to conduct this fair research data management. Maybe teaching materials are needed for that. So teaching materials that are not only specific for energy systems, so they help her to specifically communicate her results to the community, but maybe even the publication of research artifacts as fair data objects are more easy with the information she finds here, and thus help her for better access and reuse in the community. So let's come to our last part here and an additional example. How do we want to integrate all of this with a wider NFDI ecosystem? And maybe it's better to understand if you see an example again. The nice thing is that there are some examples that help to understand the general idea here. The wider NFDI ecosystem, you might be familiar with this image as well. We are many different consortia in the different domains, the research domains. So NFDI for energy can be found in this area of engineering sciences. And of course, many services have been developed and are developed in the other domains. And we do have one consortia that is even only specifically built for setting up those services that all other consortia might need, or many other consortia might need, that is space for NFDI that you see at the bottom of this very nice image here. So let's take one example. How do we integrate with a wider NFDI ecosystem? We go to the example of NFDI for energy terminology services. So what is a terminology? First, to put this. Terminologies are a body of terms that is used with a particular technical application in a subject of study, summarized and visualized in ontologies. So that is a, well, quite long definition. So what does this mean actually? So what do people understand by a specific term? If you're from energy systems, let's take the term transformer. So what is a transformer? It means something completely different when you are an energy researcher or if you are not. So a transformer might be, well, something that you might know from the movies. But if you're an energy researcher, you think about voltage transformation. So you need an explanation for that, because that is definitely well, a difference. And there are examples even within the energy domain, of course, where you need a clear definition of what a term actually means for those that need it. And to alleviate interoperability, of course, that is very important. So the terminology service is now needed to explore energy-related ontologies effortlessly with our terminology services and find out the most recent version of these definitions. So in NFDI for energy, we orchestrate and link existing terminology service-related offers from the broader community. And this goes into directions. So as you can see on the left-hand side, you see the terminology service provided by TIB. And you see here that we linked in the NFDI for energy project, and from this, different ontologies lie behind this system. On the right-hand side, you see the open energy platform, and the open energy platform is very important for us because it's the perfect starting point for NFDI for energy. It offers the ontology view not only on different concepts in energy systems, but on results as well. So you will find results of many different projects within this open energy platform. And you can see here that we linked this so that the next time you might deliver some results to the open energy platform in some area, you can first check with the terminology service if you chose the right term for the results that you want to deliver here. So that is an approach to better work with these ontologies and the semantic approach that lies behind. So we extended the existing terminology service from TIB and linked it to the existing open energy platform. That is the general idea here. So maybe this is a good representative to see that interconnection of all the work that already has been done is part of what we really have to do. And that's important for us because, of course, we want to have a reuse of results even on this level. So not only in the area of our energy system research results, but on the tool level as well. And that is what you, for example, can see here. So let's sum up. We want to build this open ecosystem for fair research. We want to establish the community services. Maybe you got a glimpse into what kind of services we mean and how these services might make your research life more easy or maybe even faster. That is nice as well, because then you can spend more time on interesting research questions. We want to simplify the identification of simulation-based models and show you how to use it. So we want to support you in using this in our community. We want to enable and motivate the involvement of society. That is still an issue, but we need it very, very early in our energy research. And we want to better cooperate with our industry, because industry in energy systems is very important for all the price setting issues, but for innovation as well, because this is a very innovative area. And without our business partners, we will not have the results that we want to see out there in the future energy systems. And of course, we want to integrate our provided services within the wider system. So to sum up, before we come to the question session, if you want to get more information, of course, you can either go to our website. LinkedIn is quite active here, or you might even subscribe for our newsletter and get the latest information from time to time. So with this, I'm happy to answer some questions, and yeah, see you then.
So thank you very much, Astrid, for your presentation and all the details of the energy system research. At that point, we're going to say a quick goodbye on YouTube and stop the streaming.